Good morning. So today's my topic is on dimension analysis and model studies. So I have the little bit introduction on this one. Okay. So the introduction for this one. So many of the practical real flow problem in fluid mechanics can be solved by the equation and the analytical procedure. So most of the fluid mechanics problems can be cleared by using this equation or analytical method procedure. So however, the same solution, however, the solution of some real fluids, the problem depends heavily on the experimental data. For this experimental data, we used this dimension analysis in model studies to clear all the difficult problems where we can use these solutions. So some the experimental work in the laboratory is not only the time consuming but also the expensive. We cannot do all these experiments in a laboratory setup. We could not possible because it have consumed a lot of amount due to the expenses. We use the experiment in a real time one. So the main goal is to extract the maximum information from the fewest experiment. In this regard, the dimensional analysis is the important to helps in correlating the analytical result with the experimental data and to predict the prototype behavior from the measurement on the model. So actually, we have to done a model based on the prototype size. So based on the size of the prototype, we done a model. So from the done a model, we give some of the forces to act out on the model. So based on the forces acting on the model, how the prototype and model can react. So same similar things we have to taken into the action, and we have to conclude that so the some of the real fluids, whether it is depend or resist the forces acting, any external forces acting on the body. So the same thing we have to find out. So next slide. So I have shown the dimensions and units. So how to calculate the dimensions and units? So in dimension analysis, we are only concentrated with the nature of dimension. It's a quality or not a its quantity. Okay. So when just imagine the size, the size has been reduced to the scale, some scale. So as the prototype model, we can convert the size based on the scale ratio we converted into the model. So dimensions are the properties which can be measured in mass, length, and time. Okay. So these three things are the basic dimensions. That is, we call it as the physical dimensions. These three things have been used in the upcoming problems. That is mass, length, and time, etc. So units are the standard elements we use to quantify these dimension in kg meter second. So what are the data has been given, the each and the every unit has been converted into kg meter and seconds. Whether it is Newton, have to take in a kg. Whether the length we have take it in a meter, then its physical dimension is length. Likewise, the time have the physical dimension, we having the unit second, and its physical dimension, we take it as a t. So the somewhat similar, it is given in the below. The following are the fundamental dimensions, that is m, l, t. So m, which denotes the kilogram, that is m. Its symbol is m. Always denote the whatever the value will be given in a kilogram, convert into a m, that is the most. So whatever the dimension will be given in the length, that is nothing the kilometer or meter or feet or inches. So somewhat whatever it may given. So the same thing we have to taken in the length. Okay. Then next thing is time. So time we have to calculate its unit in a second. So the same thing we have to take in the fundamental dimension, that is the t. So these three are the fundamental dimension or physical quantities we have to use in the dimension analysis, that is m, l, and t. Next, we have the secondary quantity. Some of the secondary or derived dimensions, or so secondary dimension are those quantities which possesses more than the one fundamental dimension. So it does not consumed with the one dimension, it have more than the one fundamental dimensions. So then we consider this one into a secondary or derived dimensions. From the geometry, we calculate the area. So area can be calculated in the meter square. So length into breadth, that is meter into meter, we have meter square for the area. From the it is arrived to the physical quantity as length square. As in the volume, the same well as we know that the volume is denoted in a we have the unit for the volume meter cube, then it will be converted in a physical quantity in a L cube. Okay, then move to the kinetic. Okay. So kinetic in nothing but we know that the kinetic forces or velocity and acceleration. For the kinetic, we having the unit for the velocity as meter per second. So here the meter per second, meter is denoted in a length, then second is denoted in a time. So L by T, which is nothing but L T inverse. For acceleration due to gravity, that is G, which is 9.81, its unit is meter per second square. We converted into the physical quantity, that is L by T square. So here we note that L T minus 2. For dynamic, we take force. Force is calculated in its units in Newton. So Newton, that is the combination of the two or more fundamental dimensions. Newton, that is M into L divided by T. So it may be taken as M L T inverse. Density, that nothing but kg per meter cube. It's also combination of one or two more dimensions. That is M divided by L cube. So it's also denoted in M L minus 3. So these are the data has been derived in a secondary or derived dimensions. Okay. So next, so find the dimension for the followings. Also, I have given some of the points. So stress, work, power, kinetic energy, dynamic viscosity, kinematic viscosity, surface tension, angular velocity, momentum. So likewise, we have to find out the dimension for this data. Okay. So use of dimensional analysis. So how to use the dimensional analysis, where it can use the, so what the benefits we have get from using the dimensional analysis. Okay. So conversion from one dimensional unit to another. So likewise what we done in the previous slide. So same thing we have to do, the conversion from one dimensional unit to another dimensional unit. So when it is a physical quantity, we could not convert it into another dimension. So other than the physical quantity, we have to convert it into the another dimension. So the geometric quantity. So when it is geometric quantity or otherwise, it may be a dynamic quantity, or otherwise it may be a kinetic quantity. We can convert it into the another quantity. Okay. So checking units of equation. So that is the dimensionally homogeneity. So dimensionally homogeneity is nothing but, so dimensional homogeneity means the term from the right hand side which is equal to the term from the left hand side. So when the equation, we have taken an example that v equal to c into root of mi. So that is Check's equation we have taken for the arriving or solving for the dimensional homogeneity. When velocity is meter per second, so the same unit has been arrived on the right hand side. It means that it's a dimensional homogeneity. Then next we have to see about the defining dimension relationship between Rayleigh's method and Buckingham's pi theorem method. Okay, from the Rayleigh's method we use the up to the 4 number of variables we can use for finding the dimension analysis. So when the number of variables are increased to more than the 5, 6, 7, we can use by using solving the Buckingham's pi theorem method. So the final one is model analysis. Okay, so model analysis, that is the biggest concept. So model analysis, which have a lot of ideas and a lot of concept has been included in the model analysis. So it's nothing but we have a lot of similarities, and what's similarities has been taken from the model and the prototypes. So those things has been discussed in the model analysis. Next, so dimensional homogeneity. So from the previous slide, we take some formulas to arrive that LHS, which is equal to the RHS. So when the term from the left hand side, which is equal to the term from the right hand side, this is called as dimensional homogeneity. So how the dimensional homogeneity has been elaborately we said. So dimensional homogeneity means the dimension in each equation on both sides are equal. Okay. So how we say that both sides of the equation are equal? So we take down the equation, what are the equation we may be taken, and we have chosen the equation and we have to check whether the equation is dimensionally homogeneity or not. Here we have the equation that is V equal to root of 2G into H. Okay, so the example equation we have to be taken and check out that whether the equation is dimensionally homogeneity or not. Okay, so here we know we take the first we have to take the left hand side. Okay, and we have to find out the dimension for the left hand side. Here b equal to root of 2gh. Okay, so this is the equation we have been taken. So from the left hand side we have the velocity. For the velocity we have the physical quantity. So velocity have the unit of meter per second. So that meter per second is converted into the physical quantity. Meter is taken in a length, then second is taken in a time. Okay, so that's why we are putting L divided by T. So from the denominator, which is transferred to the numerator, we put LT inverse. So that's the dimension we are getting on the left hand side. So the same dimension should get on the right hand side. It means that it is dimensionally homogeneity. So here we have to the check whether it satisfies or not. So here we take the dimension on the RHS side. So here it is given root of 2GH. So any numerical does not we consider the numerical value. Only we are taking the alphabetical values for calculating these dimensions. So here two alphabeticals are given. One is gravity and another one is the height. Okay. So gravity, which means that gravity have the unit of meter per second square. Okay. So gravity having the unit of meter per second square, then height will be calculated in a meter. It's having the unit in a meter. So these two things has been converted in the physical quantities. So meter will be converted into physical quantity as length. Then second seconds will converted into the physical quantities as a time. So that's why we are putting L divided by T power 2. So that is meter per second square. We are putting L divided by T square into height. So height is denoted in a L, that is meter is calculated converted in a physical quantity as a L. Okay, here multiplying with L into L square divided by T square. From the root we have to take and we getting the answer as L by T. So from the denominator to numerator, it have been taken as LT inverse. So here for the dimension for the RHS side, we get LT inverse. While comparing with the LHS, which is equal to the RHS, both the dimensions will be the equal. So we conclude with this equation. The equation V equal to root of 2GH is a dimensionally homogeneity. It can be used in any system of the units. So we satisfy that the condition. We say that the equation will be dimensionally homogeneity. Okay, so likewise you have the another two equation. We can solve this equation whether the equation will be the dimensional homogeneity or either or not. Okay, so first the equation also Q equal to A into V. Okay, so here Q of which is having the unit of meter cube per second. So A is nothing but the area, then V is nothing but the velocity. So area will be calculated in the meter square. Unit will be the meter square. Then velocity having the unit of meter per second. A little bit it will satisfy the term from the right hand side and term from the left hand side. So the first equation also dimensionally homogeneity. We said that the first equation also dimensionally homogeneity. So same ways we have to move into the second one, and we have to find out whether it is a dimensional homogeneity or not. So already we discussed in the previous slide that is about the Rayleigh's method and Buckingham's pi theorem. So where we can use this Rayleigh's method? Okay, so when the number of variables from a maximum variables from 3 to 4 only can be used by solving this Rayleigh's method. When the values will exit to the 4, we cannot solve the problems by using the Buckingham's pi, the Rayleigh's method. So from that situation, we move to the solving of problem by using the Buckingham's pi method. So from the neat explanation, we can discuss. So Rayleigh's method to define the relationship among the variables. Okay. So variables is nothing but we have given the so what are the velocity? We're having the it's also variable, acceleration due to gravity variable. So likewise, the variable will be given in a problem. So from that problem, whether we have solved or not by using this Rayleigh's method. Okay. So this method is used to determine the expression for the variable which depends upon the maximum of 3 or 4 variables only. So only solving the expression only 3 to 4, either 3 or 4. So the maximum limit to the 4 variables. Max beyond the 4, we cannot use this Rayleigh's method to solve the problems. So under that situation, we move to the Buckingham's pi theorem. Okay. From this, so the methodology how it can be exposed as a mathematically how the function has been written. So the all the things has been given in the slide. So methodology, when let take the x is a function. Okay, so we have to consider the x is the function of x1 is a variable, one variable, whether it is a velocity, whatever will be the data will be given in a question. We have to put that function of f. It means that f x is depends upon the x1, x2, x3. Okay, it can be mathematically written that x is a function of x1, x2, x3. Here I note the x1, x2, x3. So these may be given in a question as a what are the variables? That's velocity, either acceleration, whether physical quantity, whether dynamic quantity, whether kinematic quantities, whatever it may be given. Okay, so from the given, we take this all the function of sum of the variable. Okay, so then this also can be written as x equal to k of, that's a variable we can use instead of k, of. So whatever things we may be used. So here k is a constant and the a and b, c are the arbitrary powers. So these powers has been expressed in the formula and we have to find out the value for this a, b, c. The value of a, b, c are obtained by comparing the powers of the fundamental dimension on both sides. So this is the method we have been used in the Rayleigh's method. So we express some of the on problems based on this Rayleigh's method. So here they given find the expression for the discharge. Discharge is it's having the symbol of Q in an open channel flow. When Q is depends upon the area A and velocity B. So here they given it depends upon what it depends upon means it depends that the discharge is mainly depends upon the area and the velocity. So we in solution we given q equal to k into a power. So here a and b are the arbitrary powers, small a and small b are the arbitrary powers. So in here q depends. So k where k is a non-dimensional constant. Here k we are using as a constant one. Okay, so that's a given. So that's a non-dimensional constant. Okay, so from that equation we are solving by using the Rayleigh's method. So we use some of the arbitrary constant for capital A and capital V. Okay, so here having discharge. So discharge we are having Q. So for Q the unit is meter cube per second. So there is no kilogram. So that's why we are putting m naught. So here meter is calculated as meter L cube. Then seconds are taken, which is meter cube per second. So per second is taken as time inverse. Then substituting the constant k, then we know that the length will be the more meter. Meter will be taken in a physical quantity as a meter. For area, the unit is meter square. We have to put the L square divided by arbitrary power A. Then we have the velocity. Velocity having the unit meter per second square. Meter in length. Second square is T inverse into arbitrary constant, arbitrary power as B. So equating the power of m and t. So first we have to, we know we don't have any m in the above equation. So here it is m is available, but m power is 0. So the entire thing will be the power of m will be the 0. So we have not considered the m naught value. So we move to the power of power of L, power of L. Okay, a power of T and L. So we have to take where the here the left side and right hand side. First we choose on the left hand side. So from the left hand side, the T value is -1, and that is power of T is -1. On the right hand side, the power of the T minus B. So we have to multiply this. B is common for the L and T. We have to multiply this B into L power B, T power minus B. So here from the right hand side, we have the value as -b. So from the solving our equation, solving this factor, we get the value of b equal to 1. Then next we have to find out the power of L. So we have to choose and where the L will be located in the right hand side and also the as well as in the left hand side. From the left hand side, we have the power of L. So power at the power of L, we have the value of 3. So we place the value of 3 here equal to from here find we where is the L. So here we have L power 2a. So we have to put power of L. We have the two values, that is 2 into a, 2a. Then here L power b. Okay, so this b arbitrary power will multiply into the L and T. So we get b in the right hand side. So which is 3 equal to 2a plus b. Okay, so already we find the value for b. So 1. Here you have to substitute the value b equal to 1. So we getting 2a plus 1, okay, equal to 3. So by all the solving, we get the value as 1. So here it is given that. So for value of a and b, we have been solved. So in this ab value, you have to solve in the equation number 1. Okay. By solving ab value in the equation number 1, by solving this equation number 1, we get q equal to constant k a power 1 into v power 1, which means that q equal to a into v. So like this, we have to use in a Rayleigh's method. So the example for solving the problem in a Rayleigh's method. Okay. So one more problem has been solved in a Rayleigh's method. Okay. So the another problem. So next we move into the Buckingham's pi theorem. Okay. So Buckingham's pi theorem, it means that already we discussed in the slide of Rayleigh's method. In a Rayleigh's method, the when the variables is more than 3 or 4, we cannot solve by using the Buckingham Rayleigh's method. So apart from that, we have been using